isn't it? Cool. All right, welcome back everyone. So first of all, I just want to touch on, I've had a question about the assignment, and I understand that there's possibly some others as well. So the question I received was about whether the training simulation has to be in an area that has not been researched before. So does it have to be a completely novel area? No, it does not. So there's been, you know, a million engineering training things, like the example I used with, manufacturing airplanes, or that aircraft engineering thing is an example that I am familiar with because I reviewed a paper on it. But that is not to say that you couldn't do something like that. But if you do, well, actually for any field or area that you choose to take, you should do some background research and see, has it been done before? If so, what worked well, what didn't work well? If it's a completely new area, obviously there's not going to be that, and that's fine, but then you should maybe do a little bit of reading around in fact, regardless of what you do, a little bit of reading around how they usually train for these things, and then come up with your plan, your strategy for how you would train it. If it's already been done in VR, look at the literature, say what worked well, what didn't work well, and then your thing comes around, what would you do differently? That make sense? Cool. Did you have another question? Or?
I just wanted to have a general discussion about what we're supposed to do, and so I think.
Okay, cool. Yeah. So yeah, I mean, it is again. If you have any other questions, please let me know. But it is supposed to be more of a creative exercise than anything particularly scientific at this point. So if you have an idea and you found someone else who's already done it, that's absolutely fine. That happens all the time in science and research. Very few things that anyone has ever done in the last 400 years has been completely novel. So in that case, it's a case of learning as much as you can about what has been done, trying to find the weaknesses, the strengths, what hasn't been worked. There's a famous saying, research is standing on the shoulders of giants, which I'm a firm believer on. Your research should be based on all the research which came earlier, because that means that everyone who does that pushes the boundary of human knowledge a little bit further. You're not expected to always start at the ground, because your impact will probably be less noticeable than, if it's something like incredibly novel and just game-changing, you get attention, but otherwise most people, the best they can hope for in their lives, and this sounds a bit defeatist, is to make a small improvement. But if millions of scientists, academics, researchers, designers, engineers, artists, whatever, make a small improvement, it makes the world a better place overall. Okay, cool. So any other questions, concerns, comments about the assignment? No? Okay, cool. Has anyone started it yet? No? That's all right. It's all good. You've got plenty of time to do so. But it's probably worth at least having a look, having a think about what you might like to do. You don't want to leave things too late, because otherwise it becomes a real chore. The earlier you can get started, even if it's just a case of thinking, what would I do? And then maybe just going on Google and searching virtual reality, deep sea welding exercises. Virtual reality, deep sea welding training, and seeing if there's any material out there. If there is, read a paper, look at the reference. Have you guys done much about literature reviews in the Friday sessions yet, or not much? Okay, so that's going to come up soon. But I guess the short explanation of how to sort of start: grab a paper, read the abstract. If the abstract sounds reasonable, you might want to start. You read the introduction, you read the conclusion, and you sort of, this is how I do it anyway, sort of work your way in, because you find often in the middle of the paper is where you get to all or I guess probably 2/3, 3/4 of the way through is where you get to the quite boring stuff, like all the results and analysis and stuff, which is probably less interesting unless you decide that this is absolutely the paper that you want to base your work on, than perhaps reading the conclusion and they say, we found that this exercise allowed people to perform better by 83%. That's probably way more interesting than looking at, massive screeds of numbers and statistics. But one good thing to do is, if you read the abstract and it sounds interesting, the first two sections, so the introduction and the background, will tend to have a lot of references. So you go through, and if they're like, in this paper, these people did X, Y, Z, it'll have a little number or whatever for it, flip to the back, look at the references, read that paper. And you sort of end up very quickly expanding out. And if the authors of the papers that you're reading have done a good job, just by reading the papers that they reference and the papers that they reference, you know, after about 2 or 3 tiers of that, you suddenly know a lot about that field of research because everyone's referencing each other's work. So you just got to find one really good paper most of the time, and that will help you flesh out your understanding of the entire area just by following that chain through. Okay, anyway, let's get back to where we were. So we talked last week about programming basics. Has anyone done anything with processing? Yes, one person, 2 people.
Yeah.
Cool. Sorry, I'm not going to take a tally, but it is, you know, one of these things that you really benefit from sitting down and doing this yourself. And probably you'll have some homework by Thursday because I think we'll make it far enough for you guys to actually look at some processing examples and do some stuff around that. So we looked at some real basic stuff, variables, types, arrays, comments. We talked about various operators and control statements. Did we get to functions? Yeah, I think we did, didn't we? Yeah. I've actually been teaching some of this material in the other course that I'm teaching at the same time because none of them have any Java-based programming language. They're all Python-based, so which, considering they're supposed to be using Unity, is pretty useless. So I'm kind of teaching the same material at 2 different speeds in 2 different classes. So if I don't talk about something that is on the slides, or if I do talk about something I've already covered, please let me know because it's kind of hard to figure out where I am in each of them. Okay, so did we go all the way through this, naming, calling? Yeah, I think we did, didn't we?
We haven't seen overloading, I think.
Okay, cool.
But I think we would, yeah.
All right, no, that's all good. We will pick up from there. So I will write a program. I probably should have started this before the lectures. Okay. Okay, so let's write a program. Yeah, so this equals my array brackets I. And let's say void setup int array 1 equals, oops, 1, 2, 3, 4, 5. Oh no, that's right. Let's run that, make sure that works. Cool. Okay, so we looked at a few examples like this last week, and hopefully this is still something that, you know, given enough time, you guys could figure out what it's doing without having to run the code. Not that you'll ever be asked to do that in this course, but being able to look at a piece of code and understand what it does without running it. If it's this sort of length is not necessarily something that should be too big an ask. So if you remember, whenever we have a function, we have to have everything in a function. We can no longer just write code. And the setup function is a special function that processing offers that runs when we first run our program. So if we look in our setup function, we create an array of integers called array1, which has the values 1, 2, 3, 4, 5. And then we print out the value that we get back from calling the sum all numbers function with that array. All good? Happy? And then if we go up and look at our sum all numbers function, we'll see it takes an int array called myArray as an argument, so that's the data that gets passed into it. It has we set up a new variable called sum, which is an integer with a value of 0. Then we use our for loop to loop through the array for the length of it, so as long as the array is, we'll go up to, but not including that number, starting from 0. So if the array is of length 5, we'll go 0, 1, 2, 3, 4. And then we take that array value, which is stored in there, add it to sum and return sum. So all this function does is basically takes an array and adds up all the numbers in it. And then we print out the value.
Sorry.
Yes.
Do you start writing the function always on top, or you can?
No. So there are certain languages where you have to do that. C, for example, is one where you need to declare a function before you use it. Java, processing, C#, all those languages you don't have to. So they can be in any order. Yeah, good question though. So yeah, there is for Java and C#, which are the two languages we're going to focus on in this course, it doesn't matter the order of the functions. As long as the functions are there, it's smart enough to find them. In C, you do have to make sure that you always at least say that there is going to be a function called sum all numbers before you call it, even if the code for it's later on. Okay, so everyone's happy with that function, how it works, hopefully. I wouldn't expect at this point in time you guys to be able to knock that out in one go like I just did, but certainly I would hope if you were sort of running it a little bit at a time, you know, write a couple lines of code, hit run, see if there's any errors, fix the errors, run it, doesn't quite work, you would hopefully be able to eventually get to that point. So if we have an integer array, this function works fine. Oops, let's do something different. 2, 4, 6, 8, 10. So now we have this, so we have an int array, this takes an int array, and that'll work fine. But what happens if we try and use the same function with a floating array? So you'll see down here, it's a little bit hard to read, I'm sorry, the function sum all numbers float array does not exist. So we remember, if you guys remember, we can't convert a floating point number into an integer without casting it because we don't know how to treat it. Would that work? Oh, helps if I spell it right. Yeah, so we could try and cast it from a floating array to an integer array. However, that's not something that processing or Java can do. It's just one of the problems with, or one of the limitations of the language. We could, if we wanted to, create an int array and then loop through everything in the floating point array and convert it from an int to a float, that would work. But that still wouldn't necessarily give us the result we want if we did actually want the sum of these floating point numbers. So let's make these a little bit more interesting and actually give them floating point values. So what are we supposed to do? Well, we could have sum all numbers integer and sum all numbers float and have a separate one for every different data type that we wanted, but then it becomes a burden on the programmer to think about, okay, I need to call the integer version of this, and that's called sum all numbers int, and the floating point, and that's called sum all numbers float, or is it int or is it integer, so on and so forth. So because we're all lazy programmers, let's make it easier on ourselves. We just want a function called sum all numbers, which can sum all numbers, and it doesn't actually really care whether they're ints or floats or whatever. So one way of doing that is to use a process called function overloading or method overloading, depending on whether you call them functions or methods. And how that works is basically by using the same name but different arguments, we can actually overload the same function so that and leave it up to the compiler or the program to figure out what function it needs to call at what time. So you can see the only difference when I copied and pasted this one is I've changed from an int array to a float array, and that's really all we need to do in this case. As long as the number of arguments are different, it can usually, most of the time, it can usually figure out which one we're going to call, because we can tell the difference between an integer array and a floating point array by looking at how we've defined them down here. Passing them into arguments will allow the computer to say, oh, I've got an integer array, is there a function which takes an integer array? Oh, there is this one here. I have a floating point array. Is there one which takes a floating point array? There is this one here. So if I run this now, we'll end up with two values, 15 and 31.8, which correspond to 15 is 1, 2, 3, 4, 5 added up, and 31.8 is all of these numbers added up. You'll notice it actually says 31.800001. That's what I was talking about when we were talking about the difference between floating points and doubles. Sometimes there's rounding errors. This is a rounding error. So if it was really important that was 31.8, not 31.800001, it might be worth using doubles rather than floats there, but I'm not too fussed about it at the moment. So just to show you how that works, I am in the integer function. I'm in the floating point function. So we can see when we call the sum all numbers array 1 with the integers, it's going to pop up here, print I'm in the integer function, and then it's going to work its way through this and return, and that value will get printed out. Then we set up array 2, which is a floating point array. We call sum all numbers. It's going to pop up here, print I'm in the floating point function. It's figured out which one it needs to use based on the arguments. So it prints that out, and then it prints it out. So we can see it is using the two separate functions. It's able to figure out which function it needs to call based on what arguments we're passing into it. That does mean, though, that if we then have a double array, I'm just going to copy and paste these because a double or float and a double will work, that it's going to complain again because, well, it's actually a slightly different error now than we had before. It says the function sum all numbers expects parameters like sum all numbers int. So it's actually changed the argument. It used to just say that it needs to be an integer. Now it says it's not applicable for doubles because we have two separate arrays which take two different things. But the error message is slightly different, but the point is still the same. We have one for int, we have one for float, but we do not have one for double. So I could copy and paste this and make it a double one as well. And so you can think about this, if we were making some sort of math library, we might just say, okay, let's do one for ints, floats, doubles, longs, all the different data types, and we can tuck that away somewhere, and as long as somebody knows that there is a function called sum all numbers, they can pass whatever they want into it, and they will get a corresponding value out. Other languages, and I suspect probably in processing as well, there are other ways of doing it, like called templates, which allow you to just say, you will get an array of something, and this is how you should deal with it. But templates are not something we're going to cover in this course. You can do the same thing with these as you can with a template. A template just, again, allows you to write less code because we're lazy and want to try and write the minimum amount of code absolutely possible. So that's the idea of overloading. Overloading allows us to use the same function name for multiple functions as long as they take different arguments. So it could be pass in an integer or do some calculations on an integer, do some calculations on a floating point number. Or it could be, in the example of our println, it could be println can take an integer, println can take a float, println can take a string. So somewhere if you downloaded the processing source code and looked in it, you would see something like this for println. So you'd have println int, println float, println string, or something to that. At least if you were going to write your own println function, you could do it in that way. Provide a println function for every different data type which it could possibly take. So the other thing which is sort of tied up with overloading is this idea, well, actually before we jump in, everyone happy with that? That makes sense to everyone? We can have multiple functions with the same name as long as they have different arguments. You can also, I mean, in this case, these two functions do the same thing. They add up the numbers. This could do something completely different. So this could, instead of adding up the numbers, could subtract all the numbers. Oh, Jesus, that's loud. So instead of adding up all the numbers, this could subtract all the numbers. Better get rid of that double. And it will work just fine. This is a really terrible idea. If you are overloading a function, your functions should do the same thing. There's nothing stopping you, and as far as the program is concerned, it does not care what your functions do, but you're really shooting yourself in the foot if you have overloaded functions which behave differently, because the whole reason we do overloaded functions is so we don't have to remember all these functions. We just know there is a function which will take a whole bunch of data types and perform this action on it. If they perform different actions, you've actually made more work for yourself, because now you're like, well, actually, there's one which deals with ints, which does this thing, and there's one which deals with floats, which does it slightly differently, and yeah. So let me just save this. I'll try and, when I write enough code like this, I'll try and save it out so I can remember to upload it. What are we doing here? Overloading. So yeah, I'll put all these things on learn. I think I did put one of the ones from last week on. So, okay. So optional arguments work in the same way. So let's say I have void setup, and let's do one void greeting. Okay, so I have a function called greeting that I can call from my setup function, and that will print out hello. That's cool, but what if I want a little bit more of a personalized greeting? I could have another function, greeting, which takes a string and when it's passed in a string, it will say hello concatenated with that name. So we have two functions here, one which takes no arguments and just prints out hello, one which takes a name and prints out hello plus name. So when we see plus in a string like that, it basically just means stick those two strings together. We talked about that a little bit on Thursday, and I didn't make it explicitly clear. So this is called optional arguments. And as you can see, it's very similar to how our overloading worked, except in overloading we had they all had the same argument, or the same number of arguments. It had an integer array or a floating point array or whatever. In this one, we're changing the number of arguments. So on this one, it takes no arguments. This one, it takes one argument. We could have another one which takes two arguments. So this one takes a string for a name and a string for the weather. So we could say hello name, space, weather, day isn't it. And now we have another one. So we pass in the name, optional. We have a function which takes no arguments, a function which takes one argument, and a function which takes two arguments. And if I run them, we'll see hello Adrian, sunny day, isn't it? So we're basically, again, reusing the same function, but we have optional arguments. So we don't have to pass in all of these, and the function will behave differently as it goes. So there is another way of doing that as well. What we could do is we could say, so this is one way of doing optional arguments. The other way is we can actually assign them a value in the heading. So actually, I won't copy and delete that because that's going to make things confusing. Let's create a new one, greeting2, string name, string weather. So, try to make it big enough. So we have these three different things which have a different number of arguments, and each one behaves slightly differently. But if we just want to have one function and have some default values, what we can actually do is pass them in the construct or in the arguments and give them a value by putting equals to something. So we could say string name equals person, and what that means is if we don't pass in a value for name will be person by default. Likewise, what's something we'd have for the weather? Blank. Super original. So now when we print out this value, actually let's just copy and paste this one. So if we call greeting2 now, which works a little bit differently, let's comment out these so we can see. So if I pass in greeting2 Adrian sunny, it will use the value of Adrian for name, and it will use the value of sunny for weather, and hopefully if this works, it doesn't. Okay, let's just forget I talked about that because that works differently in processing than I remember as it works in C#. So let's...
The optional parameter has to be at the end of the, I don't know if you can style
You should be, as long as they all are, you should be able to. Let me just double check. I do apologize for that. I should have checked it before. That's how it works in C#. Processing optional parameter. Do. Okay, so it doesn't look like you can do this in processing, at least from that scrolling to that one thing. So let's just pretend I never talked about that, and if we need to do optional arguments, I might talk about that when we get to C# and explain what I was trying to communicate there. But if we want to have optional arguments in processing, let's just run with this example. So we can just exclude them. What we could actually do if we wanted to sort of make it a little bit simpler so we don't have these things, is we could say in our greeting function, if no name or password is passed, or no name or whether is passed in, let's call the greeting function again. Like that. And so what happens now is if I call greeting with no name or no person, it's going to call the greeting function with the name person as the name and blank as the weather. So this if I call it like this, we're going to go into setup, we're going to call greeting, it's going to pop up here, and then it's going to call this greeting down here with the name and weather. And likewise we could do here, greeting, name, blank. And now, so if I pass in no arguments, we're going to call the function greeting with the name person and the name and the weather blank. If I call greeting with a name, we're going to call greeting with name and the weather blank. And if I call greeting with the name and the weather, it's going to print this out. So if I print these, run these three pieces of code again, we're going to say for the first one, greeting, no arguments. It's going to pop up here. It's going to say greeting person blank, and then we'll call this function hello person blank day, isn't it? If I call greeting with a name, it calls this function, which will then call this function with name as the name that it's gotten, and blank as the weather. So I'll say hello Adrian blank day, isn't it? Or if I call greeting Adrian sunny, so the name and the weather, it'll call this function, and then it'll say hello Adrian blank day, isn't it? Does that hopefully make sense? So it's a little bit of a convoluted way of doing things. Certainly the way I was trying to do it before, which is how C# and everything works. In the break I'll check to see if there is a way beyond that one thing that I sort of skimmed over, because it can be quite helpful if you want something which has some default value. So if I don't want to pass what weather it is, it'll just say something different. It can be quite useful having optional arguments, but it doesn't necessarily look like processing can handle it in the same way that C# does, which again just comes down to lazy programming. This actually works in exactly the same way or gives you exactly the same results, but it does mean we have to write out a bunch of different functions, whereas in C# we don't. We can just say, if you're not given a value for this, set that value to something. Okay, so does that make sense, hopefully? Again, I will make this, actually no, I'll leave those ones in there. I'll make these available online, download them, test them, change them, see if you guys can make sense of it, see if you guys can change it to do some other behavior and do what you expect. But otherwise, if everyone's happy with that, let's move on to programming and processing. So you might say, well, what have we been doing so far? Everything we've been doing so far, other than a few things like how processing doesn't appear to support processing optional arguments the way that other languages do. Everything we've covered so far is basically the same in all C family languages, and will be very similar in other languages like Python and stuff like that. So it's all pretty generic. What we're looking at when we talk about programming and processing is things that are specific to processing and won't necessarily work in other programming languages. So processing provides a number of functions we can implement or functions we can call in order to control our application. So let's open up a new one of these. So I've listed a few of these standard functions. I don't know if that's what processing gives them, but that's how other people, myself included, would describe them. And these, the first lot I've called event functions. So event functions are functions that processing will call when something happens. So the one we've looked at so far is the setup method. So we know that the setup method gets called when we start running our program. So if I put in here println setup and hit run. There it is. I was going to say, why did that not pop up? So we can see we have this setup function, and in it we write setup. We can see down here setup is being written. So something is calling our setup function, and as I said, processing behind the scenes is calling that for us when we run our program. So if I wrote a different function, my other setup function, and run that, we'll see that setup gets printed, but my other setup function doesn't, and that's because nothing's calling this function. Setup is a special function that processing has that other programming languages don't, that processing will call when your program first starts, and that allows you to set up everything that you would need for your program while it's running. Whereas this one here, my other setup function, has no meaning to anything other than you as the programmer, so it just sits there until you decide you want to call it. Make sense? Okay. Yes.
The setup will be just called once?
Just called once. Yep. So setup gets called once and exactly once, and that gets called as soon as I push this play button, plus or minus, as soon as I get it. So we can see setup only gets printed once. Which brings me on to the next point, which thank you for so nicely segueing into it. There is another function called draw. Now you can tell these, well actually if we go back to the processing.org website and we pop into reference, we can see in the structure thing, there's a whole bunch of various structure things, but we can see down here the setup function, and in fact any of these things with brackets after them will be functions, and we can look at that and see some examples. And the setup function is run once when the program starts, which is what I've been saying. It's used to define initial environment properties such as screen size, load media, blah, 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 blah. But effectively that is a function which processing will call once and only once when the program starts. So we can see there's a bunch of other functions in here, but the next one we're going to look at is this draw function. So again, some examples. Called directly after setup, the draw function continuously executes the lines of code inside its block until the program is stopped or no loop is called. Draw is called automatically and should never be called explicitly. All programs update the screen at the end of draw, never earlier. Okay, so that's a lot of text, which maybe doesn't make too much sense. But what we can take away from it is that draw is a function that processing will call again. And in fact, draw is a function that processing will call as often as it can, non-stop until the program exits. So you're asking before setup only gets called once, that's correct. Draw gets called as long as your program is running, as many times as it can. So we see the setup here. If I now have my draw function with draw printed in it and hit play, you'll see draw is printed over and over again. It's kind of hard to actually keep track because it very quickly slides off the bottom of the screen. But if I scroll up, we can see draw has been printed a ton of times. And it will probably be printed as fast as my monitor is displaying, so it's probably about 30 times a second or thereabouts. And if we scroll all the way back to the top, we'll see our setup function right at the top. So setup has been called once, right at the beginning, and then draw has been called from then on, non-stop. So if I wanted to know, for using these, the setup function will be where I set up everything in my program, hence the name. So if I wanted to load a picture, I might load it in setup. If I wanted to set the values of some variables, I'd do that in setup. And then draw is something that I want to do every frame. So I want to add one to the value of some number every frame, or I want to draw a picture to the screen every frame, or I want to move a picture and then draw it every frame will be in that draw method. There is a bunch of other functions as well. Oops. So let's just get rid of this draw one because otherwise it's just going to drown out everything else we see. processing functions. So there's one in here, mouse moved. And again, you'll see it highlights it with bold blue. And does anyone want to hazard a guess at what the mouse moved, when the mouse moved function will be called? When the mouse moves, look at that. So you'll see at the moment nothing's happening. I am moving my mouse, but it's not being called. That's because, as we've talked about very briefly at the beginning, processing will create a window for us. So we can see there's this window floating here, which you can just sort of read PROCE. So that's the processing window that's been given to us. So what processing does is it will call the mouse move function when the mouse moves over this processing window. So sure enough, now that I'm moving in there, we can see mouse moved. When I move it out, we won't see anything because it's stopped printing, but all that text is still there. But what we can do is let's, and I'll explain this in a second. So let's set up a variable called x, print out the value of x, and then add 1 to the value every mouse moved function so we can keep track. So we can see the setup in there. As I move around, that value is increasing. If I stop, it stopped increasing. I'm not moving my mouse anymore. Or if I move it out of the window and move it around, it's no longer increasing. So the mouse move function will only increase or only be called when I'm inside that processing window. Does that make sense? So one thing I just wanted to come back to, we'll talk about this a little bit later on once we get into object-oriented programming. You'll notice that I put my integer or my variable x up here, right at the very top of the code. So you might be wondering, why did I put it up there and why did I not put it into the mouse moved thing? Because that's where I'm using it. Why would I not have it right there where I'm using it? And the problem for that is there is a concept in programming called scope or variable scope. And what scope refers to is how long a variable is remembered by the program. So if you remember, we talked about at the very start of this, I drew that box and I talked about pigeonholing, and then I opened up an image of a pigeonhole on Google Images because I realized that some people might not know what I was talking about. But we talked about this concept of we have some memory in our computer, and when we say int x, the program will say, give me a little piece of memory to put some values in. So if we have a really, really big program, we don't want to necessarily keep track of every variable which we ever use for the lifetime of the program, because we might use something once just to do a little calculation and then throw it away. So the way we work around that is we have this idea of scope. So the scope defines how long a variable is stored for. So if we're using a variable just to sum up some numbers or something, and then we do something with it and then we throw it away, the scope allows us to say only store the value of this for this long, and when I'm finished with it, you can clean up that memory. I don't need that anymore, and that memory goes back to the computer and can be used for other things. If we didn't do that, every program which you ever run would very quickly run out of memory, and then you'd use Microsoft Word or Internet Explorer or whatever for like 5 minutes, and you'd have to restart your program because it's run out of memory. And in fact, the problems with scope is one of the big problems why programs run out of memory. One of them, not the only one. So the concept of scope basically defines how long our variables live for. And the scope of a variable can usually be determined by looking at these squiggly brackets. So if I want to know what the scope of a variable is, so in this case int x, I just look and see where its nearest enclosing squiggly brackets are. So in this case, this is the one immediately before it, and actually processing is quite handy in that if I select it, it will highlight the other squiggly bracket. So I can see that this int x equals 0, the scope of it goes from this squiggly bracket to that squiggly bracket. So what happens here is when my mouse move function gets called, it says create me a new integer called x, set its value to 0, print out that value, add 1 to it, and then when we hit that other closing squiggly bracket, it basically says to the computer, I'm done with this x now, you can get rid of it. So then what happens is when mouse moved gets called again, it comes in here and it says create me a new value, a new variable called x, set its value to 0, print out it out, and so on and so forth. So if I run this, does anyone want to hazard a guess at what's going to be printed whenever I move my mouse over the window? So previously it was printing out mouse moved and then a number which always increased by 1. With this int x defined within the mouse move function with only having that scope, what do we think it's going to print out? Well, just 0 actually, because we add, so it starts at 0, we print out the value and then we add 1 to it. So yeah, but yeah, it's never, the value is never going to increase because each time we come into this function, we create a new variable called x, print it out, add 1 to its value, and then immediately throw it away again. So what I can do, if I don't want that to happen, is I can put my, my variable outside the function, and you can kind of think of, to use that idea of scope is defined by squiggly brackets, you can kind of imagine that your entire program has a set of squiggly brackets at the start and the end. So anything which isn't in a function, this int x here, this int x here, actually let's put it nearer the top to make it easier to see, effectively lives from this squiggly bracket here to that squiggly bracket here. So this int will last through all of these function calls because its scope is larger than that. In reality, if I try and put these squiggly brackets in here, processing's going to complain because it doesn't know what the hell those squiggly brackets mean, but that is effectively what's happening. So this int x gets set up once, and then from then on, it will stay in memory until my program finishes running. So the value will gradually increase. The other important thing to remember about scope as well is that if the scope of this x value is that, so it only lasts for the length of the lifetime of this mouse move function, it means that no other function has access to that variable. So you see down here, this variable x does not exist. That's because there is no variable called x within the scope of this function. It can't see it because it's hidden in some other function. But if I make this a public variable or a global variable by putting it in the scope of my entire program, like that, it now won't complain anymore because that function or that variable does actually exist within the scope of that function. So scope is quite a complicated thing for people who are new to programming, so if it seems a bit confusing, don't worry, that's perfectly normal. Everyone struggles. But the good thing about scope with processing and C# and all these things is that if you've, well, for most of the mistakes you can make with scope, the compiler will let you know straight away. You'll be trying to access something outside of its scope and it'll say something like variable x doesn't exist, which immediately should tell you that x is not in the scope of that function or it's not in the scope of wherever you're trying to call it. So a lot of the time you'll be saved by the compiler will say, I don't actually know what this variable is. And if you see that, you have to then say, okay, go back, what is the scope of this variable? Where is it being destroyed and cleaned up? Okay, that was a bit of an aside, but we're going to talk about scope, come back to scope when we talk about object-oriented programming anyway, so it doesn't hurt to learn about it now. All right, so we have another function here, key pressed. Does anyone want to hazard a guess when key pressed will be called? When you press a key, that's right. So if I have my window highlighted and press some keys, it would say key pressed. So let's just talk a little bit about the mouse moved and key pressed function. So I can move my mouse over this and I can see that my mouse is moving because that number keeps getting bigger. I can press some keys and see that keys are being pressed because it's printing stuff out. But that's not entirely useful because, you know, there's probably some meaning to my mouse moving. If I want to know when the mouse is moved, I probably want to know a little bit more, like whereabouts my mouse is. So processing provides a couple of variables for the mouse position, and they are called the mouse X and mouse Y. So mouse X and mouse Y are the X coordinates, so the coordinate from left to right for X, and the coordinate from top to bottom for Y. So if I print mouse moved and then X and then Y, we'll see that first number stores the X value of my mouse. So as I'm moving this along from left to right, you can see it's getting bigger and bigger right up until, so by default, the size of the screen is 100, so it will start at 0 and go all the way to 99. And likewise the Y, so the second number there, will start at 0 at the top, and as I go down, it'll get bigger and bigger and bigger and bigger until we get to 99. So this point in the top left corner, top left corner is 0, X is 0, Y is 0. This is X is 100, Y is 0. This is X is 100, Y is 100. And this is X is 0, Y is 100. So that's the size of this, 100 by 100. And mouse X and mouse Y will tell me whereabouts within that window my mouse is. And the point it's measuring is the very top left-hand corner of the mouse pointer. So the very tip of it. Cool. All right, so that's mouse moved. Key pressed works in the same way, and there is a function or variable called key that processing gives us. And just like how the processing functions are blue and bold, the processing variables are reddy, pinky colored to let us know that they are special variables. So if I push a letter like A, you see it says A, D-R-A-N. So the keys that I pressed will appear in this key function. So now I could have some behavior. If key equals A, say, so we've tied up these functions and these variables with this if statement that we learnt about last week. So we're checking in the key pressed function if the key, so the key which was pressed, is equal to A. So in this case, the key stores a char. So we want to use the single quotation marks, not the double quotation marks. If we try and use it, processing will complain that they're incompatible types, char and string, so it'll let us know that there's a problem. But I can say if key is equal to the character value of A, it will print one message, otherwise it will print a different one. So if I push A, it'll say you push the A button, well done, and if I push anything else, it will print out those values. So now we've actually got a program which responds to user input. So I push a key and it changes its behavior based on that. We're no longer just blindly printing out variables. We actually have a program which can do something. So does that make sense?
I was wondering why we use two equal signs.
So if you have one equal sign, so if I said like that, that's an assignment. So that's saying set the value of key to be A. Having two equal signs is a comparison, so it's saying is key equal to A. If you tried to do if key equals A like that, then it's complaining. The message is a little bit confusing. It says type mismatch, char does not match with Boolean, because basically what it's doing is it's trying to assign the value of key to be A, and then it's trying to compare that. And it's saying, well, you've assigned something, and now you're asking me to compare what that assignment means. I don't know, so use double equals instead. All right. Yes?
What are some of the applications of mouse moved in real time, like for tracking of screen, like usage in terms of that? Like
Yeah, so I mean, it could be anything. Say you wanted to, it's jumping ahead a little bit, but say we have something on the screen that we want to know if the user has clicked on. If we know whereabouts on the screen that is, and the user presses, there's another function actually, mouse pressed, which gets called when the user presses a button. I could say if the mouse X is greater than, let's do it actually. So the first thing I'm going to do, so we talked about these event functions. These are events that, or functions that processing will call for us. So we just fill out what they need to do, and then processing will call them. So we fill out what should happen when the setup function gets called. We should fill out what happens when the draw function gets called, etc., etc. The action functions are functions that we can call to make processing do something. So the first thing that I want to talk, first one is size. So size is something that we usually call in the setup function, and what that does is allows us to set the size of the window. So I mentioned before that the window is by default 100 pixels by 100 pixels, and you could see the window was quite small. Here I've set it to 512 pixels by 512 pixels, and now you can see it's much larger, and as I move my mouse over it, you can see it's going to go from 0 to 511 in the horizontal, and likewise from 0, I can't quite get my mouse on there, to 511 in the vertical. So we've made the window much bigger, and we can actually see it and do useful things with it. So there is another function called, the size function takes two arguments, the width of the window and the height of the window. And it doesn't have to be square, it could be whatever shape I want. And when I run that, you'll see now it's quite long, but not very high, or I could make it really high, but quite narrow. Whatever size I want my window to be, I can set by calling the size function. Cool? Okay, so that's our size function. We usually call that in the setup method because unless we want to constantly change the size of our window, it makes sense to set up once. I mean, there's not many programs which change the size of the window automatically. I mean, I can click and drag this window to make it the size I want, but you can imagine if it was constantly like jumping around like that, it'd be a pain to use. So that's usually done in the setup method and just left. So with the draw method, so we're going to look at a function called Rect now. So Rect will draw a rectangle on our screen. And we do that by passing in 4 values. We need to pass in where the top left corner should be. So that's from the left value. So say I want it 100 pixels from the left by 200 pixels from the top. And then we give it the width and the height. So 400 pixels wide and 200 pixels high. And we'd usually put that in the draw method because we want to draw, this is a drawing function, so we want to draw at every frame so that it's always there. So we can see now I've got a rectangle drawn on my screen. That will be, if I can move this so we can see. So if I move to the top left corner, that is 100 pixels out, so 99 is because it starts from 0, so that's 100 pixels. And from the top, that top left corner is 200. So that's where this rect 100 by 200, that defines where the top left corner is. And then its width is 400, so if we took 100 and add 400, that will give us the value of 500, which is that right-hand side. And likewise, if we start from the top of 200 and add 200 to the height, that's 400, so that bottom should be at 400. So this point here will be 100 by 200. This point here will be 100 plus 400, so 500 by 200. This is 500 by 400, so add the two together, and so on and so forth. Hopefully you guys can follow along with that. It's getting confusing to me to try and remember. So you asked the question, where would that mouse move function come in handy? So if I know the coordinates of this window, of this rectangle that I've drawn to be 100 by 200 by, if we add those together, 500 by 400, what I can do is I can test in here to see if the mouse position is in that. So if mouse X, so it's got to be at least greater than or equal to 99. And mouse X has to be less than or equal to 500. That is the size of the, or less than 500, sorry. That is the width of it. So it goes from 99 pixels to 499 pixels in the X. And the mouse Y position, so it's a vertical position, is going to go from 199 because it starts at 0, and the Y position is less than 400 because that's its maximum size. Mouse is in box. Oops, mouse Y. So this function or this if statement checks to see that the mouse position is greater than or equal to 99 and less than 500, which will be horizontally in the right position for the box, and that the Y position is between 199 and 400, which is the vertical position of the box. And if so, if I move my mouse around, nothing happens until it goes into the box, and then it will say mouse is in box. Again, let's put out that X on so we can see when it does print something. So moving around, nothing's happening. Then when it's in the box, stuff is happening, and when it's out of the box, nothing's happening. So now you can think of this as we're almost designing around GUI. So that could be, instead of a box, that could be a button. And so I can tell, so mouse pressed gets called when I click a button on my mouse, button pressed. So just show you guys that. So when I tap, button pressed will come up. So I could move this code now from my mouse moved function to my mouse pressed function and say button pressed. So let's assume that box is now a button. And if I click anywhere, nothing happens. But if I click there, it says button pressed. We've just created our very first user interface element. We've created a button. Obviously quite a tedious way of doing so, and I wouldn't recommend doing it this way, but you can see that you could. I could have a ton of buttons drawn on the screen, and I would just look at each button and say, if the mouse has been pressed, was it inside this rectangle? If so, do some behavior. Does that hopefully make sense and kind of answer your question of when these functions are useful? Okay. So we've talked about the size function, we've talked about the rect function, we've actually skipped one here, and that's called background. So what background does is background sets the background color, and we pass into that the RGB value. Yep. So 2550255 will give us a lovely purple background, and so we can see we can change the color of the window. Now there is something that we need to talk about here. So let's take our rectangle that we had, let's make it a bit smaller. Actually, no, let's leave that rectangle. Let's have another rectangle so that I can give you this code and it'll still have some stuff on it. Okay, so I have the rectangle we talked about before. Let's just forget about that. This second rectangle though, I've given it, instead of giving it an X and a Y position as numbers, I've given them as these two integer variables, X and Y. Pardon me. And I've said that the width and height is 100 by 100. And what that allows me to do is add or change the value of X and Y. So if I hit play now, we have two rectangles, the one we saw before, but we have this other rectangle which has an X and a Y for variable for its positions, and every time let's get rid of that X++. Every time we call the draw method, we add 1 to the X value. So what that's going to mean is every time we draw it at, the very first one will be at 0 by 0, then we're going to add 1 to the X value, so we'll draw it 1 by 0, 2 by 0, 3 by 0, 4 by 0. So as you can imagine, that box is going to gradually move along. It's probably going to move along, oh actually it's not too bad. So it's gradually sliding along the screen. But you might be asking, well, what is this big black line that's leaving behind that? And that is actually let's make plus equals 5 to make this, explain this a little bit better. That is actually the last place that the box was visible. So we can see, it looked like a black line before, but now moving a little bit further, we can actually see that it's actually the last time that box was drawn. So it draws it, and then it draws it on top, and then it draws it on top, and then it draws it on top. So we end up with this effect of constantly drawing on top of it. So that may be an effect you want. You want to leave this trail of where it was before, but maybe you don't. You want it to be more like you'd think, and it would sort of slide along and leave no trail. And the way to do that is by moving this background function from setup into draw. Because it's the difference between the background function, if we're talking about, I'll leave that stuff up here, I'll draw it over this side, is basically like telling the screen to wipe everything clear. So if I don't have that background function, effectively what I do is I say draw the box here, and then in the next screen draw the box here, and then the next screen draw the box here, draw the box here, and so on. You can see we're leaving this trail along as we go. What the background function does is basically say clear the screen with a certain color. So I would say draw the box here, and then in my next background method, if I call, my next draw method, if I call background first, it says clear everything off the screen and draw it here. And then we go into the draw function, clear the screen, draw it here. And so instead of leaving this trail, instead we're actually clearing the screen every frame. Oops. And we end up with something like this. So now we can see it's moving along and it's not leaving any kind of trail. And if I shrink that down so you can see a bit better, we can see it's moving along nice and smoothly and there's no trail being left behind, because at each frame, or each time it calls draw, it's clearing the screen before it puts everything else in there. For that same reason, we have to be a little bit careful. If you think about, let me just comment out some of this code. So if we think about this example here, we have just a purple background and this rectangle, nothing's moving, we might be tempted to put it into the setup function, because that works just fine. You know, we draw the rectangle, and because we're never clearing the screen, everything will look okay until we decide that we want to put the background function in draw as well, and then that you could just see, like, for one fraction of a second, not even anymore, but you just see fraction of a second, there's the box there and then it disappears. That's because as soon as we get to this draw function, we clear the background, and because that rect only gets drawn in setup, it never gets drawn again. So that's part of the reason why the function's called draw, because you should do all your drawing in there. So ideally, you should put your background thing in the draw method so that the slate gets wiped nice and clean, everything you draw is fresh on there, we're not leaving trails. And then every item, even if it's an item which doesn't move, like this rectangle here, we should draw each frame so that we make sure that all the elements are there when we draw it. It seems a little bit counterintuitive at first, you know, why would we draw something every frame even if it's not moving? But if we don't draw everything, even if it's not moving, when we do add moving elements, those things that aren't moving are going to disappear if we just, as soon as we call background. Cool. So, does that make sense? Kind of, hopefully. So hopefully you can see now that, you know, we are actually working towards building a program which potentially does something. You know, we've got things we can click on. We have things that move. I could get a little bit creative. So let's, instead of having this x++ down here, which moves the position of our second rectangle, let's, in our key pressed function, get rid of this, which just prints out a meaningless message, and instead let's put some code in to do something interesting. So if key equals a, x minus minus. So if we press a, it's going to decrease the value of x. If key equals d, it's going to increase the value of x. If key equals w, it's going to decrease the value of y, and if key equals s, we're going to increase the value of y. So ADWS. Is anyone here a gamer? No? maybe, kind of. So if you're a gamer, WASD are the keys that you usually use to control your character. So W moves them forward, S moves them backwards, A turns to the left, D turns to the right. You'll notice when you look at them on your keyboard, they're kind of in a T shape, and that's why. So I've just used them here. And for a very similar purpose, A will move our box to the left, D will move our box to the right, W will move our box upwards, and S will move our box downwards. And now if I run this program, I can actually control the position of my box, but it's moving very slowly. So let's change these from subtracting 1 at a time or adding 1 to adding 5. And now I can actually move my box around all over the screen. So we've just created our very first game, effectively. It's not a very exciting game. It's move one box while another box stays stationary, but you can see now we actually have an interactive program. And all of this is just built upon all the stuff that we've talked about in the last few lectures. Happy? Cool. All right, let's take a short break there. We'll come back at, let's say, 10:15. Gives us about 9 minutes. So if you need to get a drink or go to the bathroom, or you want to play your game, make sure we finish at a reasonable time. All right. So, where were we up to? Okay, so we've talked about the size function. We can use that to change the size of our window. We've talked about the background function, which allows us to clear the background. There was one other thing I just wanted to mention about the background function. So when we talked about it, I said that the background function can take, or takes the red, green, blue value from 0 to 255. So if any of you aren't familiar with that, pardon me, we've got 0 to 255 is basically a byte's worth of data. So, well, 256 you can store in a byte. So that's why these values are 0 to 155. It may seem like a little bit unintuitive, but you can think about 0 as being the bottom and 255 being the top. If you've done anything with like a paint program before or whatever, it hopefully won't be too confusing. So processing, we haven't talked about this yet, but it has a number of tools as well that we can look at. And one of them is called the color selector. So we can go in here and say I want a certain color for my background. I can click on this color thing on the side, and then I can choose a color. And you can see it's breaking it up into a few different things. So there's hue, saturation, and balance, I think, HSB. I'm not sure what the B stands for. It's usually HSB, but there's the red, green, and blue. So we can stick those directly in there. 67, 245, 157. And now if I run that, I will get that green color as my background, and so on and so forth. Most of the color functions or the functions which take a color in processing will take a range of different colors, or ways of writing colors at least. So I could also pass in the hex value here. So this is if you're writing HTML. Has anyone done any HTML stuff? Yeah. So in HTML, often you'll pass in a code looking like this, and that's actually just these red, green, blue values written in hexadecimal, where 0 is 00 up to FF is 255. So we could do that. The other thing we can do with the colors in processing or all the color functions is if I pick or stick close to this left-hand side, so you can see this left-hand side goes from black all the way up to white. If I drag this thing up here and we look at the red, green, and blue colors, we'll see they start very low. Ideally, they'd start at 0, 0, 0, which is black. But as I move up, sticking close to this left-hand side, we'll see that that color gets lighter and lighter. So it passes from black through grey into white. But if we notice these red, green, and blue values, as long as I stay close to the left, will always be the same. So they start 0, 0, 0, and then as they get bigger, it's 23, 23, 23, 33, 82, 82, 82. So basically, if black is 0, 0, 0, and white is 255, every number, as long as the red, green, and blue channels are the same, will be a shade of grey. So if I wanted to make this sort of a dull grey colour, I might say 128, 128, 128, which will give me this dark grey colour, because we know that if the red, green, and blue colours are all the same, they will be a shade of grey from black to white. The reason I wanted to bring this up is because processing does this other thing, which is taking lazy programmer to a whole new extreme, where we go from being lazy to being confusing. And if I call any processing function with just one number, what that is effectively doing is saying set the red, green, and blue channels all to that one number. So if I wanted a shade of grey, rather than saying 128, 128, 128, I could just say background 128, and that will set the red, green, and blue values all to that. The reason I mention that is because quite often you'll see, a lot of windows have a white background, and quite often if you look at processing examples, they will just have background 255. So that says set the red, green, and blue values to 255, give us a white background. I personally am not a big fan of this because it's one more thing that I have to explain. It is lazy, and I usually promote being lazy, but at the same time, it's lazy to the point of confusing. I think this probably makes more sense because we can look at that and say, oh, that's the red, green, and blue values. This is basically saying the same thing, but in a slightly less intuitive way. If you showed this to someone who is a good programmer but not a processing person, they probably wouldn't be able to automatically understand what that means. If you showed that to them, they'd probably say, oh, that piece of code is probably setting the background to white. So the reason I want to mention that is because in addition to being able to teach you guys so you can write your own code, I want you to ideally be able to read other people's code and understand that as well. And a lot of the examples you will see, for some reason this is promoted in processing as being good practice. I would argue that it is not good practice. I think it is unnecessarily confusing and kind of separates processing from other types of code. Like, I've never seen, another programming language or graphics toolkit or whatever which supports just passing in one value for red, green, and blue. But for some reason in processing, that seems to be what a lot of people do. So if you see a function which takes a color and it only has one value in it, it's basically saying set the red, green, and blue to that value. But let's not do that because that's confusing. All right, cool. So size sets the size of a window. Background will clear our window and allows us to give it a color for what we declare it. If we put background in the setup function, it only gets called once. The window only gets called once. We get these trails. If we put it in the draw function, it clears it every time it draws a screen. We don't get the trails, but we need to make sure that we put all our drawing stuff in there. We've talked about Rect. Rect is kind of an interesting one in processing. So we've looked at one of the ways of calling it. So if we look at this now, we can actually see, we talked about these optional arguments. So we can have a function which takes 4 arguments or 5 arguments or 6 arguments. And Rect is one of these functions, and you can see some examples with the code next to them. So this is Rect as we would normally expect. So its X position should be at 30, so 30 in the horizontal. Its vertical position for the top left corner is 20, and its width and its height are 55 will give us this result. Here you can see one which has the same X, Y, width and height, but it has this extra variable at the end 7, or this extra argument at the end 7. And what that actually allows us to do is define how curved the corner points should be. So if we pass it in nothing, it will give us square or 90-degree corners. If we pass in a variable at the end of that, or another argument, that will give us the radius of these corners. So we can turn our square boxes like that into, let's pick a colour which make this slightly nicer to see, 52, 104. So if we wanted our player box, so this is my player here, to have curved edges instead, I can add one last argument to the end of that which defines the radius of those corners. So I give it 10, and now you can see it's got nice rounded corners, whereas our button has square corners. And we can set that radius to whatever we want. until it gets more and more spherical, or we could just use the circle function if we actually wanted to draw a circle. And there are other functions. So if we say x, y, width, height, radius, that will give us this. Or if we say x, y, width, height, and then we can say top left radius, top right radius, bottom left radius, bottom right radius. So we can define all the radiuses separately, which we see in this thing, and end up with this weird shape. So to draw a rounded rectangle at a fifth parameter, to use a different radius value for each corner, include 8 parameters, and we can see the different ways of calling this here. So A, B, C, D seems to make less sense to me than X, Y, W, H, X, Y, and width and height, but it's right because it explains what they all are down there. Yeah. So there are multiple ways of calling rect function as well, in addition to just the X, Y, top and bottom. So I mentioned if we wanted to draw a circle, there is a circle function, which will give us a circle, and that just takes the X and Y center point and the radius, or the extent they call it. So I could change my rectangle, so I don't want my player to be a rectangle anymore. I want them to be a circle, so I'd say X and Y, and then give the radius. Oops. And now we can see my player is a circle rather than a rectangle. You'll notice though that when I started, because X and Y are at 0, the circle is half off the screen. That's because rather than providing the top left corner, which kind of doesn't make sense when we're talking about rectangles because they don't have corners, the X and Y define the center point of the circle, not the top left corner. So what I might like to do instead is start this at X is 50 and Y is 50, which will start the circle at 50 by 50, and then I can move it around. So circle allows us to always draw a circle. If we wanted to draw a circle with a bit more flexibility, we can use the ellipse function, which allows us to provide the width and the height separately. So if I change this from circle to ellipse, it takes 4 arguments, the first 2 being the center point again, and then we have the width and the height. So I can change that so that it's no longer a circle, it's now an ellipse, if that is something that you feel would benefit you. Okay, so the last 2 functions, action functions, is fill and stroke. So let's go back to using our, let's go back to using our circle for our player character. So our circle is white with a black border, so is our button. That's perhaps not what is ideal. So if I wanted to change the color of a circle, you'll notice that there's nowhere in the circle function for me to provide a color. I can only provide the size and stuff. So instead, processing provides a function called fill, which allows us to define what color the fill should be, or what color the center of it. So say I want my circle to be, we're looking down on our player, so we want to have a brown haired player. So we can pick a brown color and set that color using fill, and now you'll see for some reason both our circle and our box have brown. And the reason for that is because, like having the background function, fill is a function that we set and then stays set. So if I call fill at any point in time, it sets the fill to brown, and then every time it goes around, everything gets drawn in brown. So now we don't have a white box and a brown circle, which is what we might think. We have 2 brown things because we set the fill color to brown and we just leave it at brown. If I wanted to have these as separate colors, what I could do is I could have set the fill before I draw my rectangle to white, and then set the fill before I draw my circle to brown, and that will give us more of what we expect. So now we have a white rectangle because we call fill and set it to white before we draw a rectangle, and then we set fill to brown and we draw our circle, and we get a white rectangle and a brown circle. We also have a stroke function, which allows us to set the background, or the outline, sorry, So fill and stroke. Let's do something else. So if we set our stroke to 2550255, it'll give us this lovely purple color up here, or roughly, like that. If we set stroke to 128, 128 to 128, it's going to be grey. So now we will have, it's very hard to see on the screen, but I can sort of just make it out here. We have a purple border on my button, and we have a grey border on my circle. Again, it's not particularly obvious, so let's make it white. Actually, let's do, to make them really stand out, we're going to have a black outline on the box and a white outline on the circle, which stands out a little bit better, so hopefully you can just sort of make these out. So we can change the stroke. If I didn't want an outline on my circle, I could obviously make it the same color, but there is also a no stroke function. No, there's not. There is a function which I thought was called no stroke. There is a function called no stroke. Why is that complaining? Because it's a capital S. There is a function called no stroke with a capital S, which will turn off outlines. So you can't really see it very well again, so do this on your own computer where you can have a closer look. But that has basically turned off the outline for that. And likewise, there is a no fill function with a capital F. So instead of having a fill, I could say no fill, and now when I draw my circle, it's not there at all for some, So now we have no fill and stroke. Now we will have just the outline of our circle with no body. And when I move it over things, you see that it is transparent. So the stroke allows us to define the outline if there should be one, and the fill allows us to define the fill if there should or shouldn't be one. So that allows us to have different colors for our controls, or our whatever we're drawing on the screen. So fill and stroke. Cool. So now we have a circle with no border, it's brown. We have our rectangle, which is white and has a black outline. Everyone happy with that? Cool. So they're just simple drawing functions. There's a ton of them if we look at the various things. There's a bunch of 2D primitives, which are, arcs will draw part of a curve, circles, ellipses, lines, points, quads, so on and so forth. You can have a look through all of them. The good thing is you can click on them and it'll give you a little diagram showing you what they actually look like when you draw them. So arcs can be a circle, which may or may not be filled, and so on and so forth. Right. So hopefully we can look at these examples, which used to be at the very start of my thing, and we can understand what's happening in all of these things. So this first example we see here, let me just save that. This first example here, we can see size 512, 512. We're setting the size of the window to be 512 pixels by 512 pixels. Background 255, which we know is 255, 255, 255. So we're setting the background to white. We set the fill to 255, 2550, which if we punch that into our little color selector here, 255, 2550, gives us the color yellow. And we draw a rectangle 150, 150, 150, 150. So 150 pixels from the left, 150 pixels from the top, 150 pixels wide, and 150 pixels high. So that will give us this yellow box here. Then we have fill 25500, so red is 255, green and blue is 0, so that will give us the color red. And then we're drawing an ellipse at with the center set 150 pixels from the left, 150 pixels from the top, which just happens to be the same as the top left corner of that rectangle, and its width and height are 150 as well. So hopefully we could look at that, and without even seeing that image, we could hopefully get a rough idea of what's going to appear on the screen. Or if not, we can punch it into processing, hit run, and understand why what gets drawn gets drawn.
There is a function too, determining what is behind, what is in front.
So in the case of processing, it draws from top to bottom. So, yeah, good question. Let's type the code out and have a little look. Size 512, 512, background. So we have, this is the example we just saw, and the question was, is there a way to tell what should be on top? Like, why is the circle on top of the rectangle and not vice versa? In the case of 2D processing, let me just quickly double check this to make sure I'm not lying to you guys. X, Y, yep. And Rect. Yep. So in the case of when we're drawing 2D stuff, it really just depends on the order we draw them. So here we're drawing the rectangle first, and then we're drawing the circle. So the rectangle goes down first, and then the circle goes on top of it. If I swap these around, so we draw the circle first, and then the rectangle will be on top of the circle, just because it draws from our code top to bottom. When we get into 3D graphics and stuff, we have another dimension. So we have the X and Y, so the left horizontal and the vertical, but we have another dimension, the Z, which is the depth, so how far away things are, and that allows us to say, you know, this object should be behind this object or in front of this object. But for the 2D primitives, we can't. It just depends on the order that we draw them. So you need to think a little bit about what that means, particularly if you have moving things like what's in front of the other and vice versa. When we get to 3D, we have this extra Z value, which will tell us how deep how deep compared to the screen something should be. So something with a greater depth value will be further away from me than something with a lower depth value. So we can change those depth values and it will draw them accordingly. But the 2D stuff doesn't have that because there is no concept of depth in 2D. Okay, so this is a slightly more advanced example. So the first one we did doesn't have any functions or anything like that. It just draws a couple of things on the screen. So this one, again, if we type this out, void setup, size 512, 512, background white. So we talked about having the background function in setup versus in draw. You can see here it's in the setup function, not the draw function, which we know means that trails are going to be left behind. Fill 25500, ellipse, mouse X, mouse Y, S, S. Here's the mouse moved function again. In this case, all we're doing in the mouse moved function is a little mathematical equation which uses the sine function from math, which we know moves in a curve. Let me run this. And you can see we have this weird snaky pulsating kind of thing. So what's happening in this example, our setup function, we set the size to 512, 512, we clear the background, set it to white. In our draw function, we set the fill color to red, and we draw an ellipse at the position of the mouse, so mouse X, mouse Y, with the size S. And this size S is calculated in the mouse move function. It's going to be a size of 40 plus 20 times the sine of M plus M divided by 10. So the actual function for this, the actual math behind this doesn't matter too much. The sine function basically will go from go like that. So that's why the size, our size is roughly equal to this. So it's going to increase to a number, and then it's going to decrease to a number, and so on and so forth. That number we multiply by 20, so if sine goes from 0, 1 to -1, multiplying it by this 20 here means that the size will actually go from 20 to -20, and then we add the value of 40 to that, so that will, our size will go from 60 to 20, and that is the minimum size we see here will be 20 when sine is at the bottom. The maximum size will be 60 when sine is at the top. That divided by 10 just changes the rate at which it goes, because m is increasing. So this plus plus m we haven't talked about before. Just as we said, we can do m plus plus, we can do plus plus m, and they mean exactly the same thing. Don't use plus plus m. It does actually mean something slightly different. Let me show you. Int x equals 0, int y equals 0, println x plus plus, println plus plus x, plus plus y. So x is 0, y is 0, print x plus plus, print plus plus y. Does anyone want to hazard a guess at what these two print statements are going to say? No? So one says 0, the other says 1. So what x plus plus means effectively is use x and then add 1 to the number. So in this case, the using of it is the println. So it's saying print out the value of x and then add 1 to it. What plus plus y means is add 1 to the value of y and then use it. So in this case, x, they both start as 0. We say println x plus plus means println x, then add 1 to its value. Println plus plus y means add 1 to the value and then print it. So they do work slightly differently. You will see this happen all the time. This you will almost never see. I cannot think of once I've actually seen it in the wild, other than the slide. So I probably need to just edit the slide and change that to m plus plus, so it's not confusing. And for the purposes of this example, it actually doesn't matter whether m is added to before or after the thing. It just means that the first circle we draw will be slightly bigger or smaller, like 1/10 of a number bigger or smaller. For the amount of additional confusion it causes, it's not going to have any effect. So changing that from plus plus m to m plus plus doesn't make a difference. So, pretty, seems like a complicated example, but there's really nothing we haven't looked at or talked about so far, apart from maybe this sine function. And this is a slightly complicated mathematical equation, but it's not too bad. Likewise, this would be a far less exciting example if we put the background method in draw, because then we wouldn't get the trails, we just get this pulsating circle which changes sizes because we clear at each frame. But hopefully from everything we've seen so far, this all makes sense more or less. Again, I wouldn't expect you guys to be able to write this function at the point we're at, but hopefully, with some explanation of what the value of s ends up being, you can understand why you see what you see there. And we're using functions, including the draw and mouse moved function. Okay, so processing also can be quite advanced. So if we've talked about the beginner stuff last week, we've gotten into the intermediate stuff today. Processing can also be quite advanced. So you can start setting up classes and external libraries and using stuff like that. This code here will kind of roughly give you what's seen on the right, but this is actually only part of a program. This is what's known as a class, which leads us into object-oriented programming, which is going to be the next topic we put on. Don't type this out into processing and run it and expect it to do what you see here, because it won't. This is a class which represents one of these circles, but you need something else basically creating these circles and telling them what to do. And that's what we're going to move on to with object-oriented programming. So we're not going to have time to cover this all today. It may not seem like a lot of slides, but there is there's a lot to cover in here. But it's important because object-oriented programming came about, I can't even remember when it was, like the 80s or 90s, but really gained popularity in probably the 90s. And now it's just kind of how things are done, to be honest. So when we go into Unity, everything is done in object-oriented programming. It is something which is built on top of everything we've learned so far. So everything we've learned is still completely valid. Object-oriented programming is just a different way of thinking about programming to make things hopefully easier to grasp, particularly when we're talking about large projects. Actually, maybe we'll leave that till Thursday, because what I want you guys to do is I want you guys to do a little bit of homework. Now that we've talked about programming processing, I want you guys to actually get your hands dirty, get some blood on your hands. So processing, we talked about how it has lots of little examples that you guys can have a play with, which will teach you how to do various stuff, but they're all the same and they're designed to teach you how to program. There is another website called, so Open Processing, this looks different from the last time I looked at it. Yep, so it is. They've just changed the website from the last time I looked at it, called Open Processing. And Open Processing is a place for people who write processing code to upload their processing code to share with the world. Some of these examples will be really bad, some of them will be really cool, some of them will be written really well, some of them will be written really poorly, some of them will be doing really cool, exciting things, some of them will be incredibly boring. It is your job over the next 2 days until Thursday's lecture to have a look through some of these, find one you like, try and understand how it works. So probably don't pick the most complicated looking one, because it might be more than we've covered so far, particularly considering we haven't talked about object-oriented programming. But find one that you like the look of and have a go at downloading it, trying to make it work, trying to change it, understand how it works and all that stuff. I'll put a assignment on Learn. It's not going to be graded, but it gives you guys a chance to upload, like make some tweaks and upload your stuff. And it's optional, but I would highly recommend you guys do this just to get your hands dirty. Gives you a chance to look at some real code that people other than me have written to try and tweak it, to try and understand it. So we have one example here running in the background. I move my mouse around, it makes these cool patterns, and there's kind of one which is just going on constantly. But I really should have checked this out before today, but I didn't. So let's explore this together. So you can see this is basically a repository for people to upload their code to. There is an Explore Sketches down here, which if we click on, will allow us to see a bunch of different things that people have uploaded. And being that processing is a visual program or programming language for artists, they're all probably going to be quite arty, which is fine because some of them will be better or worse. But let's have a look at one of them. I'm trying to find one which hopefully won't be too complicated. So if I click on one, this is a nice, pretty example, and there we go. So if I click on the I button, it gives me a little bit of information. This is called Particle Flow by Yasai. If I click on play, I can see what it looks like, so it's nice and pretty. And if I click on this, these two angle brackets with the slash in the middle, it will give me the code for it. So hopefully, if I'm lucky, and copy and paste this into here and hit run, it will complain that this isn't going to work, which is disappointing. Let's see if we can find another one. Okay, so this one is a bit more complicated, but will hopefully work off the bat, which it does. There we go. So now we have an example which we've taken off open processing, which does what we would expect, or it does at least what was on the label, and shows us this Fourier series here. So a Fourier series is basically when you add multiple waveforms up, what they mean. This is kind of an interesting one in that you're seeing a waveform which was produced by 3 circles, and each circle represents a sine wave or a cosine wave, and when you add them together, this is what you see. So the good thing about this is that I have all the code to it. So what I would like you guys to do is try and find one of these which works and understand how it works and make some change to it. This one is quite a complicated one, so I wouldn't expect you guys to be dealing with anything like this. But your example could be as simple as, okay, in this one we have 3 circles and it draws these lines. Let's see if I can understand what this is doing. So we have P circles, which is, okay, up here we have circles, which is our number of circles. So what happens if I change that value from 3 to 5? Now we have 4 circles for some reason. But you can sort of see, you know, this is the sort of stuff that I'd like you guys to do. Grab one of these codes and try messing around with some of the numbers. So if we go back to the example I looked at before, which was quite nice but didn't work for us, was that one there? What you could do, so this one looks a lot simpler. It's just got a setup function, a draw function, and so on and so forth. This is for processing for the web though, so it is having some issues. But we can see the main issues are highlighted. So we have var, which seems to be complaining about, and var is a JavaScript thing, which instead of having an int or a float or whatever, var just means we have a variable, and we're going to leave it up to JavaScript to figure out what that variable should be. So what we can do is let's just assume everything's a float, because that's usually a pretty safe bet. Then we have these things, functions. Function is basically a Java keyword which says that it's a function. For us, we know that it should be void instead. Create canvas is basically setting up the canvas in JavaScript. We can just use size instead to do the same thing. We have another var there. Let's change that to an int. And there appear to be no more errors. So we can run this, and lo and behold, we've just converted our program from JavaScript back into processing. So don't be necessarily put off if you copy and paste it and it doesn't work. See what the errors are. Hell, I'd be happy if you guys were able to do what I just did then and take this code, which was working in JavaScript, or JavaScript running processing, and convert it to processing, which will run in the editor like this. But then we could do, you know, try and understand this a little bit. What do these things mean? What is circle? Well, the circle is 200. Down here we have some other stuff which calculates some stuff to do with circle. I don't know, maybe that's not that useful. What else have we got? We've got this loop which goes from 0 to 500. What happens if I change that from 0 to 200? Looks like we've got a lot less dots. What if I change that from 200 to 20? Less dots again. Okay, so we now understand, even if we don't understand necessarily what's happening in all these values, we can sort of understand what various parts are. And often if you pick up someone else's code, this is a good way to sort of break it down. You know, there's, especially considering the fact that these people haven't provided any comments, which is really unfortunate, but you know, oftentimes is the way that it is. People won't comment their code. We can sort of figure out by changing some of the values and seeing what effects that has. Okay, so this is 500 dots. What if I make that 1,000 dots? Cool. What else have we got in here? We've got fill, which we know changes the color of stuff. How does this work? Well, it has this color function, 074. So that's obviously the red value is being calculated by something. What if I change that to 255.74? How does that affect it? Oh, everything's a lot greener now because I've set the green value to the maximum. So I'd just really like you guys between now and Thursday to jump on open processing, have a look through some of the examples. Some of them will be really cool, but if nothing else, they might provide you inspiration. So what about this processing, the portrait painter, what does that do? It's doing lots of little strokes to paint a portrait from nothing. Look at the code, probably it's not necessarily too bad. It's got one function called paint stroke, which seems to do the bulk of the work. And then in its draw function, it's just calling paint stroke a lot of times. So maybe that's reasonable. Download it, have a try, change some values, see what breaks, see what works. In this case, it requires some files, so it might be a little bit tricky. We haven't really talked about how to load files, but basically in processing, if we wanted to load a file, what we can do is we can go Tools, Sketch, Show Sketch folder, and that will show us where the sketch we've created is, and any files that go in that folder will be loaded. So if this one takes portrait 1, portrait 2, portrait 3, .jpg, we put portrait 1, 2, and 3 in that folder and run it, and it should load those and work. But really, have a play. This isn't graded. If this is too overwhelming, you're not able to do anything, that's fine. I'm not going to mark you down or anything because there are no marks. But it is a chance for you guys to just cut your teeth, have a go at looking at what other people are doing, see, is this something that I can understand a little bit of? Can I tweak a little bit of it? Hopefully, the ones that we do try, or you'll find one which is manageable, which works straight off the bat, like this one here, draws flowers. Can I change the color of the flower? Well, I know the fill function does that, so what do these things mean? We've got a color function here. What happens if I change that last value to 255? Everything's a bit whiter now. What happens if I change in this one here, 255? Everything's sort of a bit of shade of blue. Play with these things, try and understand. I don't expect you to understand what all these, sine, cos functions are, but if you can say, oh, well, if I change this color here, it changes the inside color of the petal, and if I change this color here, it changes the outside color of the petal, at least you're having a go at trying to learn and understand how these things work. So yeah, that's your homework for Thursday. First of all, make sure you install processing. Jump on openprocessing.org. Have a look at some examples, even if it's just going through and looking at them in the editor. What's this one do? Treasure hunt. Could be kind of interesting, could be kind of cool. You see it's got some instructions, WASD mouse, allow time for images to load at startup, so it's kind of slow to start with. But, it's a little game, yay. So this has been created in processing, and, if you're feeling particularly motivated, you might want to try and change this game to do something different. Can I go up that ladder? There we go, I can go up the ladder. So, we made a game in class today where we moved a little box around. Someone's taken this a little bit further than we did. But, it's the sort of thing which can be done with a little bit more work. Is there a way we can, because I'm guessing this one. Yeah, so you'll need, for this one, you can look at the code, but I'm suspecting this one will be a lot more involved and have a ton of stuff. It looks like if you sign up for a free account, you can download the entire project, which will include all the images and graphics and stuff as well, and have a go at it. So, you might try that. Can you change the sky color from blue to red? Can you change the jumping height of the pirate? All these sorts of things, have a go, see what you guys can come up with. Hopefully that's not too much to ask, not too overwhelming. Cool. Any questions? No. So yeah, if you're done, maybe before class, you could zip up the folder. So if you go to that open sketch, it'll show you where it is. If you just zip up the folder and upload it to processing, before class, I can unzip them all, and that way you can talk about what your demo did, what you learnt, what you changed, how it's different, and that sort of stuff. And you know, a little bit of a chance to show off what you've learned so far. Cool. Otherwise, that is it for today's lecture. We'll finish a little bit early because we're going to jump into a new topic on Thursday. So.